I'm Ben Campbell, full name Biezanek. I've been working on this subject for the last 15 years. I first became aware of this subject in 1959, something like that, when I was only 9 years old. And when I went to university to study electrical engineering, I was so horrified by what they were teaching. I mean, I was able to cope with it, but I basically saw the universe in a very different way. And I was very pleased when Clauser and Friedman, there's a background behind those formulas, there's a famous picture of John Clauser working in his laboratory there in 1972. And over the last 15 years, I've developed some language to explain what I was thinking, which is rather different to what everybody else is thinking, and also a little bit of mathematics. The subject is called quantum relativity. We need to understand what space and time are, or for a top class understanding of physics, we need to understand space and time. Now, in 1980, the CIPM, the Committee International of Weights and Measures, the P&M stands for Points and Measures or something, which is French. But anyway, they changed their definition of a meter from so many wavelengths of, I can't remember which chemical it was, a laser light anyway, and they changed it to 1/c seconds. Now that's actually 3.335 nanoseconds. So the units of space are time, and basically Einstein understood that. So if the units of space are time, then what the heck is time? Because, you know, time is not the same stuff as space. Space and time are different, and we need to understand that. And we preferably would like to have a rigorous mathematical understanding of the relationship between space and time. Einstein gave us that equation, which is okay, but I'm crossing it out, not because it's wrong, it's actually right, but because of the C factor there and the mass factor there. We don't know what mass means. And C is measured in by him. For that equation to work out, you have to have C in meters per second. Now, a meter is 3.335 nanoseconds. And so, bit of an issue there. So what does C squared mean? It starts with Leonhard Euler in about 1730 or something like that. He gave us this thing called Euler's identity, which is supposed to show something to mathematicians. And it's actually wrong. It's actually nonsense, because e to the I pi is actually a rotational. It's a rotational multiple of some quantity. So a rotational plus a number equals 0. That's crazy. Anyway, of course, to put Euler's identity right, we need to say e to the 0 plus I pi plus 1 equals 0. And we can restate that as e to the 0 times e to the I pi equals -1, of course. E to the 0 is 1, and e to the I pi means a rotation of pi radians. So what I find, and I'm going to explain why, that C should be thought of as 1 divided by -1i seconds per second, treating time as being the progression of history backwards away from the time we are at now. And so therefore I find C squared is equal to -1 in those units. And therefore I find that E naught equals minus ME, which is a slightly simpler equation than E naught equals MC squared. To be fair to everybody, I'm going to have to go through some rather boring and tedious arithmetic. The universe is actually exponential. Many people on this conference mention things like nanoseconds and nanometers. And if ever we say nanosecond, for instance, then we're saying 10 to the -9 seconds. And so whether you think that you think in exponentials, you do, because as soon as we say the word nanosecond, we're saying 10 to the -9 seconds. I'm going to describe counting from 0 to 1 or from 0 to -1 as flat earth arithmetic. But the arithmetic that we need to understand nature is actually exponential, or I'll say nature counts like this, which anybody dealing in light years or 10 to the minus 20 seconds would understand. You need a very broad range of numbers. E to the 0, this is the exponential index here. E to the 0 does equal 1, and to get to 0, you have to go to e to the minus infinity. Now, there's a problem for people with Gaussian arithmetic, as I'll call it, and that is that, or flat earth arithmetic, or conversion from flat earth arithmetic to Gaussian arithmetic, and that's that the arithmetic or the mathematics that we've been taught does not really allow you can't find what the exponential of a negative number is, or you can't express negative numbers in exponential form. And Gauss explained this in, I think, 1831. He said, don't call this +1, call it direct 1. And don't call this -1, call it inverse 1. And you can get from direct 1 to inverse 1 by a rotation of pi radians, which was sort of explained rather badly by Leonhard Euler in 1730. So quantum relativity is as old as the hills. The arithmetic that's needed for it is positive. I mean, when you consider that the I operator itself comes from Hero of Alexandria in the 1st century AD, it's just magnificent how long this story's been going on. So here I'm putting it all together. The numbers that we can count on our finger, or what I might call kindergarten arithmetic or basic simple arithmetic, those numbers are the natural anti-logarithm of the actual natural exponential magnitude number. And I need to explain what I meant by green e to the x and red e to the x. And to do that, we need to express green e to the x and red e to the x with a rotational component also in exponential form. So magnitude times polarity, this just means e to the x times a rotation of nothing. And this means e to the x times a rotation of pi radians. And Gauss said, call these direct and call that inverse. Nobody paid him any attention, but that didn't stop him from leaving it on the record. Something that I hope everybody's aware of, but I'm just going to mention it anyway, because it was a bit of a shock to me to remember this. Every finite number can be expressed in the form e to the a plus ib, where a is any number between minus infinity and plus infinity, and b also. And that can be written also as e to the a times e to the ib. It's exactly the same expression. So if you might write e to the x plus I pi, I can also write e to the x times e to the I pi. And this simple number with I pi there is just minus e to the x, or -1, where x equals 0. Now, in this Gaussian arithmetic, we need to define +1, which might sound a bit pedantic, but we've decided that polarity comes from rotation, not from like going through 0. You can't do that. So we need to explain that there's some kind of circle of unity, which gives all the possible polarities of unity or 1. And that if we have no rotation, which we'll define as the direct direction or rotation of nothing, then we could say that +1 means unity, or the whole of an imaginary unit. That's very important, because we're not counting seconds or meters or kilograms here. We're just counting an imaginary unit times a rotation of 0, which I show there. But we just need to know that that unity, or 1, means an imaginary unit, because we're not dealing in physics here, we're just dealing in mathematics. And this point in the middle here is 0, has no finite magnitude, it is infinitely tiny. And then we have a polarizing angle, which could go in either direction, but I just show the conventional direction of mathematics here. And we should call that direct. Now, there's what I mentioned at the beginning, Euler's identity, nonsense, but if we add It's a shame that we can't see that. Anyway, e to the 0 plus I pi plus 1 equals 0, which we can restate. This green box in my top right-hand corner is Euler's identity stated in a rational, correct form, and then it makes complete sense. I'm shocked when I hear mathematicians say that they don't understand or they can't visualize Euler's identity. Well, no wonder, because it was written wrongly, but it's so easy to visualize. It's silly. Here we have -1 and +1, all on the circle of unity. Don't call it direct 1 and inverse 1. Use right angles. Radians are complete nonsense. I'll explain why in a minute. The polarizing angle times the rotation of 2 right angles instead of pi radians. Absolutely no change there. I've just changed the units, my natural units of rotation, to right angles. Then we get the lateral. This language, direct, inverse, and lateral, all comes from a paper written by Carl Friedrich Gauss to the Royal Society in 1831. So e to the I 0, which means e times the rotation of nothing, e times the rotation of 1 right angle, and e times the rotation of 2 right angles, e to the power of times the. So if we take the anti-logarithm of the 0 I2, we get to 1 I2, because if we take the logarithm or the anti-logarithm of a rotational, it doesn't change the rotational. And so the anti-logarithm of e to the 0 times e to the I2 is equal to 1 I2. And we can complete this picture of number theory from e to the I3. Now I've written that as -1 I1, which -1 I1 is shorthand for 1 I3, because 1 I2 is shorthand for shorthand for 1 I2 is -1. So we can say -1 plus another right angle of rotation. The most important discovery of quantum relativity, really, apart from what it actually explains, is that I is the rotational operator. 1 times the rotation of nothing, 1 times the rotation of 1, 1 times the rotation of 2, 1 times the rotation of 3, and you're back to the beginning again. We can show here taking the square root of -1 is shown here by taking these 2 quarter or 2 unit rotations back to either plus 1 I1 and -1 I1. So -1 has 2 square roots, these 2. And so we can say that I is not the square root of -1. In fact, we need I to explain any number at all. So you can't see my title there, but this is called the Fundamental Theory of Finite Natural Numbers. The finite comes in there because we don't discuss 0. It's infinitely small. Magnitude is exponential in these directions. This is just showing the polarities. The 4 polarities. Well, Gauss described these 3 polarities. He didn't bother to mention inverse, lateral, but it's there. We could also, instead, I've just shown the fundamental theory of finite natural numbers there in graphical form, but we can also show it in algebraic form. The Euler identity, if I restate it into the proper form, which just means putting a 0 before the I pi, plus 1 equals 0. Let us exchange radians for right angles to reveal what I'll call the Biezanek identity, which is e to the 0 plus I omega equals e to the 0 times e to the I omega, where omega is an angle measured or calibrated in right angles, equals 1 I omega for all finite omega. And that's just an algebraic form of the diagram I showed on the previous page. But omega must always appear to be identical to omega mod 4. And so the Biezanek identity is similar to the Euler identity, except the Euler identity is constrained to only be meaningful with pi radians, and the Biezanek identity is good for all finite angles, positive and negative. And this is just a summary of the fundamental theory of finite natural numbers. This line along the top is looking at what I'll call the FNN number plane as a side view, with the 0 point there with inverse numbers, direct numbers, and showing how they're connected through rotation with the obvious. So we don't call this imaginary anymore. The imaginary word needs to go, and that's called lateral. And this one, which I don't show down here, is inverse lateral. A circle of unity, one iomega, and a vanishing point. So we've got different arithmetic that we need for quantum relativity than we would have for Einstein's relativity. So what I'm showing here is a dashed dot and dashed purple line. I'm calling that the observable universal event horizon at time now. It has infinite spatial extent, but you don't need to worry about that infinite part for now. The one-dimensional presentation of space now, the units are in seconds as defined by the CIPM. And the history of what happened upon the event horizon of time now lies within this blue shaded historic space. The historic image falls into here. The units of this historic depth going down here are in lateral seconds. Mathematically, that is 1 seconds, but I'll just use the abbreviation I seconds. Outside of this blue space-time space, or the spatial domain, we have the quantum domain. This is Maxwell's 377 ohm superconductive waveguide of free space, or I call it the quantum domain. That is everything lying above the Peck line, as it were, intimately in our future. And there's also the gravitational domain, which is also infinite, and that's at time 0, which is infinite depth, or history infinite. So where does this come from? 1972, Clauser and Friedman, they actually showed the instant quanta jump for 2 entangled quanta, which had got to different places in space. But the reason for that is that they both are tied together by the same historic emitter. So I'm showing here an emission event occurring on the event horizon of time now, as this, as you were, travels across towards the observation event 300 million meters away. The historic emitter falls back by 1 I second into historic space. And then we get this instant jump at observation, and that gives us 1 I second of reversed history, or unwound history, if you like, and 1 second across space. Now, here is a formal statement of quantum relativity. We must forget and unlearn that we ever heard the absurd classical term, the speed of light. However, there really does exist an apparent wave velocity. The apparent wave velocity is 1 divided by -1 I. The square of the apparent wave velocity, that is c squared, is inverse unity, 1I2, or also known as -1. Therefore, both the strong and the weak nuclear forces are gravitational, because c squared is -1. The graviton has a 0 apparent radius. Integrate Einstein's field equations just as they stand. So although I've basically trashed his special theory, I've actually totally depend upon his general theory. And here is a diagram showing the QR cosmological energy balance model. The membrane there is a bit distorted by what I'm showing as a vertical dimension. That is a dummy dimension, or dummy variable, showing the gravitational space scale compression. The graviton is down here. It has 0 apparent radius, and the shape of this curve is just given by integrating Einstein's field equations. pure general relativity using a two-dimensional space model. Space is a mirage. The observer observes the history of her own event horizon. This diagram explains why light slows in matter, because as you get close to matter, the scale of space and time is compressed. So as the light passes through the glass, there's more space for it to go through than you thought there was by measuring from outside the glass. And you see our proton consists of quantized energetic particles that achieve cavity resonance within a gravitational energy hull. Einstein gave us this equation as part of special relativity. And as I've already said, it's sort of right, but it's so distorted because he thinks he knows what space and time are, and he doesn't, unfortunately. And I learned what space and time is from the CIPM, and the CIPM discovered what space and time are from Einstein. So basically, poor old Einstein just didn't have quite enough time to think about it. Maybe he also aged a bit. But c squared is -1. One I, two right angles, or -1. And so understanding C requires my Biezanek finite natural number theory. And ME is the quantum energy that is trapped in the gravity hull, which I've depicted here. In fact, that's all, of course, in one place. There's just an infinitely small graviton in the middle. This is just pure standard model of the atom from the quantum physicists. Within the quantum relativity model, the cosmological depth of the proton is shown to be infinite. To see this, merely apply general relativity, as you now know it, to a graviton of 0 apparent radius. And we've also learned about a strong nuclear force, and that's just nonsense that you need to add to maintain the fantasy. Quantum relativity explains that this so-called force is nothing but our old friend, gravity. Now, just to summarize, the universe in quantum relativity terms consists of a real quantum domain, which is where everything actually goes on, except for another real domain, which is the gravitational domain. And those two domains are infinitely separated. And what we experience in space and time could be described as the universal event horizon at time now, where we see light. But you could also describe it as the detectable universal escape horizon of time 0, which is, if you want to talk about gravity. And the blue space in between is infinitely deep in terms of history, and that is the space-time domain, a four-dimensional mirage. And so what's real in the universe is the quantum domain and the gravitational domain, and the space-time between it is a sort of synthesized space and time, which is synthesized mainly by the quantum domain, so using the gravitational domain to create the illusion of time and matter. Now, what are the benefits of understanding quantum relativity? I want to just change my screen a bit. My view is blocking partly what I want to read. General physics. Light slows in glass. Why? Because there's more space in the glass than we thought. Instant action at a distance, as detected by Clauser and Friedman and many others since, of course. Both entangled quanta are both entangled with the same historic emitter. Charge radius to gamma wavelength. The apparent charge radius is 841 atometers. The gamma wavelength, where gamma energy is radiated from a nucleon, a proton, basically, that's been crushed, or and needs to get rid of some surplus energy. And the gamma wavelength has 800,000 atometers, so there's 1,000 to 1. But of course, we need to think about quarter wave dipoles, and I end up with saying that the proton charge phase exists in a deeply compressed gravitational scale of space, about 250 times scale compression. We get another benefit is we get Newtonian mechanics compatible relativity. say goodbye to Einstein's contraclassical nonsensical version of the special theory. And the final benefit for general physics is that Newtonian gravity becomes general theory compatible. Einstein's general theory and classical Newtonian gravity suddenly make mathematically identical statements. In astrophysics, it gets a lot more interesting, and quantum relativity was really discovered because of my cosmological work rather than work with very small things like notional gravitons and charge phases. The deep space redshifts that we can observe in our telescopes are a macrogravitational deflation of historic apparent scale. 13.8 GA, 13.8 billion years, is merely the time constant of the exponential deflation of the historic apparent scale, and that's actually an optical illusion. The cosmic microwave background is caused by galactic core body cross-firing at a range of 295 billion light years, or 295 billion years ago. This subject of quantum cosmology, or QR cosmology, came from my work that I did with mass compaction mechanics, which is just basically explaining the classical mechanics of the generic formation of stars and planets from dark matter. So another benefit in the cosmological realm is that we end up with a mystery-free universe. No more what was there before the Big Bang. The spatial mirage has infinite virtual age. No more what is dark matter. It's the stuff that makes stars and planets. No more dark energy. That's just a fiddle factor. No such energy exists. And then I just need to have a go at everyone. So I'll just say Galileo was misled. Everything is in the middle of the universe, but from the observer's point of view, only the observer counts. So you can't tell the middle of the universe. Everybody's in the middle of the universe. Even if you're on Mars, you're in the middle of the universe. And so it's a rather strange way of looking at things. But if we just go back to the previous slide, if you look at those general physics benefits, they're pretty compelling once you understand them. You know, do you really want to live in a physical world where you don't understand why light appears to slow in glass? Do you really want to have the spooky instant action at a distance, or would you rather have an understanding of physics where that's the obvious outcome? But the big boy for me always was the charge radius to gamma wavelength discrepancy. I mean, that's so huge. And you know that the areal for the gamma wavelength must be the charge face of an individual proton, because you get exactly the same kind of radiation from a nuclear fission or a nuclear fusion reaction. And so the only way that could be, the only common factor is that it's protons that are doing the radiating. And how do the neutrons get rid of their energy? Well, in quantum relativity, in the quantum relativity model, there's no such thing as a proton and a neutron. They're all proton neutrons. In other words, the protonness of any particular nucleon is jumping around wherever it needs to be. And so whenever if a neutron contains excess energy inside a nucleus, then it just becomes a proton and gets rid of its energy. And I just use a quarter wave dipole model for the want of something better. But if you go back to my original explanation of number theory, you can understand why the quarter wave dipole is important, because the natural unit of angle in natural number theory is the quarter wave. And so I'd just like to leave it there. Thanks very much for listening.